Hi there, hey, this is Clint Mason with Kaizen Well Solutions. It's been a while since I've made any videos, but I wanted to talk about a fairly new product or a spin on a product that has had some very positive results. It's basically the patented tapered multi-stage plunger lift tool and we've been using it at unconventional gas wells for deliquification. I don't think it's limited to that, but that's where we've put them in, and these have been used with Saudi Aramco overseas. The patent is a joint patent between myself and Saudi Aramco, and I'll just talk a little bit about this and what's been going on, how it's been working. I think there's opportunities in North America for this system. Unfortunately, a lot of the well completions are not set up for it here. But we'll talk about it, and maybe you'll see some opportunity in your areas. So really basically what we do here is we got plunger lift, and here's the operating range of a standard plunger lift, and that's GLR, or standard cubic feet of gas per barrel per 1,000 feet of well depth. So we're saying we need 450 plus, and I think 450 is probably on the very bottom end. Most of the time for a conventional type plunger lift, we're looking for 600 to 800 for a simple system. Less than that, it can be more difficult to run, especially deeper wells. Then we have what was the conventional two-stage plunger that was used in monobore. So you have plunger at the bottom, about bottom 40% of the well, and then you move up and you put a intermediate spring and another plunger that runs in the top 60% of the well, kind of an average like that. And you can see that we can run this as low as about 250, and the window would be somewhere between that 250 and 450 standard cubic feet per barrel per 1,000, and then below that we're looking at rod lift. So with our new system, well, before we get into that, what are the pros and the cons? First of all, well, the pros of plunger lift is it's simple installation, requires no power on site typically. It's a slick line, wireline installation, doesn't require rigs typically. There's minimum workover cost and probably the lowest capex or opex cost in putting a system in. The cons for a plunger lift, well, by itself, is there is a limited operating range. As you were seeing, there's a minimum of say 200 standard cubic feet per barrel per 1,000 feet of depth, and of course it goes up from there, but there's a lower limit and where it's effective. And then there's also a fluid total fluid volume limit where you just can't make enough cycles in a day to lift more than a certain amount of fluid. And a good rule of thumb is plunger lift itself will lift between 100 to 150 barrels a day max, depending on the well. Now, if you got a real strong well and the plunger's only doing a small percent of the work, of course you can lift hundreds of barrels. We've got wells that are doing 700-800 barrels a day, but it's really the plunger lift is only doing a very small percentage of the work, and the well itself, once you kind of clear its throat, is unloading a lot of fluid after the plunger, and that's where you're getting those high numbers. Then you have gas lift. It's a pretty simple installation, has a really wide operating range. If you're a side pocket, you might have slickline intervention. Conventionally, you're going to have rig intervention, of course. But on side pocket, there's minimum workover, but it also has a lower limit where it becomes inefficient, and also it has a higher limit, but those high limits are usually in the thousands of barrels. But when you go from true gas lift to deliquification, you're 2 3/8, you're somewhere around 150 to 200 barrels a day. Once you get below that, you really can't run gas lift like gas lift, and you have to go into what's called deliquification, which means we have to inject more and more gas or ensure the entire tube string is above critical rate to lift that liquid. Where a true gas lift, it's not about velocity or critical rate, it's about being able to change the density of the liquid, gasify it, and that liquid then stretching out in the well's own bottom hole pressure, pushing it out. But some downsides to it, or cons, are major infrastructure for the gas supply, you have to put in, can have a very high capex in the initial design, and especially if you're trying to retrofit later, it's even higher. Rod lift, wide operating range, proven track record, major infrastructure cost. You've got power supply you have to put in there. You have issues with handling gas, handling solids. There's workover requirements, and there's a very high CapEx, OpEx cost in these. So these are some of the struggles in trying to pick the right system. Currently in a plunger lift application, you have kind of a single stage where the plunger's at the bottom. It runs from, and we'll use just a fairly simple number. We'll say this well is 10,000 feet, 3,300 meters deep. And that plunger is going to run from the top of the spring back up to the lubricator at surface. So when we look at it, we were talking about, you know, kind of the range it'll work in, and let's say we need 400 minimum or 500 minimum standard cubic feet per barrel per 1,000 feet of depth. Well, it's going to be, if we were doing 100 barrels, it's going to be 100 barrels at 500 standard cubic feet is going to be what are we going to be, 50,000 standard cubic feet times 10,000 or times 10. So we're going to have something like 500,000 of gas to lift that liquid in here. And then if you look at gas lift hybrid, well, we can make the gas whatever, and this is the Gapple situation. We're not really focused too much on that. But then when we look at the original multi-stage in a monobore, what happens there is, because we can lift the plunger, we've got two plungers now. So if this is the same 10,000 foot well, okay, the upper plunger is set at 6,000 feet, and the bottom plunger runs from 10,000 to 6,000, and then this plunger runs from 6,000 to surface. Now when you do that calculation, you need much less gas because a plunger is only traveling 6,000 feet versus 10,000 feet. So 500 standard cubic feet times 100 barrels times 6,000, or 6 because it's per 1,000 foot, gives you a much lower gas requirement. So that's really how this impacts your way the plunger will work in your well. So you can lift a lot more fluid with a lot less gas in a dual stage. The downside with this type of system is that you have the plunger stopped in a monobore, and it creates a restriction. It's got to flow around the plunger and around the spring. Everything's in the flow path. And if you have a well where you're trying to flow for an extended period of time after the plunger cycles and you'll unload the fluid, you can start creating hydrates or other issues. You just have extra restriction there. So it's not a great solution for wells that have a little higher gas rate but high liquid volumes. So it works really good on, you know, little stripper oil wells where you basically cycle it, unload the fluid, and shut it in right again. That's where the multi-stage monobore plunger works really well. When we get into the difference here, so here we have the monobore, all 2 3/8 tubing, for example, spring, plunger, intermediate spring that has a spring at the bottom, spring at the top, and your upper plunger, and that, so they run up there. Anytime this plunger stops, it's in the flow. And then we have the tapered system where we've got 2 3/8 pipe. We go up, say, 50% of the total distance. So at 5,000 feet in a 10,000 foot well, we'd have a crossover. And then we would go to 2 7/8. And in that crossover, we land this assembly, which basically has a flow path around similar design, like in our Kaizen radial flow lubricator, that has a tremendous amount of flow through capacity. And what happens is when that plunger comes up into that 2 7/8, so it's a 2 3/8 plunger, it travels up, goes into the entry of the sleeve, and it rides up. And then once it's in this sleeve, there's actually bypasses that allow the gas to go around the plunger and around the spring that's in here, through the seal and pack off, and then back out of this plunger back into the 2 7/8. So it reduces any kind of flow restriction. So where this one is great for very low GLR stripper oil wells, this system is really designed for higher gas rate wells but with high fluid volumes. So we can move a lot more fluid with the gas that we have versus, say, a conventional single spring system. So where we're saying, and you know, these are just kind of generalizations, but in a typical plunger lift well, you're going to be limited to the plunger actually lifting around 100 barrels a day, maybe 150. In this system, because we can make many more cycles, again, in a monobore single plunger, you would have to shut in long enough to get down to 10,000 feet and then long enough open to come back up. Where in this, you're only going 5,000 feet. So your off time is half as long. Your rise time is half as long, which means you can do a lot more cycles. Basically, we can double the cycles per day, lifting more fluid because of the number of cycles we can make. And instead of 100 or 150, we're doing 200 to 300 barrels a day very easily, which we've done overseas in Saudi Arabia. And it's been quite amazing, really, when you look at some of the solutions they've had. So monobore 2-stage, you can see here that here's your wellhead pressure, here's your casing pressure. Liquid load was about 450 psi. And when we converted that into the tapered multi-spring, we actually got the liquid load down to 270 psi average. And the result of that was we were moving more than double the liquid lift per cycle, or per day. We were allowed to do we could do longer after flow was achieved. And so we increased production and gas flow time, and we increased the amount of fluid that we could lift just because we could do more cycles. And here's an example, GLR requirements comparisons. Single stage plunger, that's saying 450. I still think that's a little tight, but that's what we would use. That's our kind of minimum rule of thumb. Conventional multi-stage or monobore, around 300, 250. Rod lift, we would have a gas rate of 100 or less. And then the patented multi-tapered system is, you know, we're at 200 MCF or SCF per barrel per 1,000 feet depth, and we're able to outproduce. So we need much less gas to move the same amount of fluid, and you can see here there's quite a difference. And then on the other side, liquid lifting capacity, well, here we have a single stage, a conventional multi-stage and monobore, and then we have the multi-stage, and this is a comparison on a, you know, of these wells. So these are real life comparisons on how the wells were performing with these different applications. So in short was plunger lift, again, here's the capacity, here's your conventional 2-stage kind of, here's the extended 2-stage tapered string versus the monobore, how much it covers, and here's your rod lift window of operation. So really, there's a big opportunity here to move a lot more fluid with a lot less gas, make more cycles per day with this monobore, and still at high gas rates or higher gas rates. So it's an interesting concept, been very successful so far on its applications overseas. Looking for opportunities in the United States and in Canada. Again, I believe unconventional shale is probably where we're going to see an opportunity for this. But it's a simple modification that can run in major, result in major design improvements. Tapered multi-stage plunger lift tool has proven to increase liquid rates with lower GLR, provides economic alternative to rod lift and gas lift, adds environmental benefits at no power with very little, or say solar power or battery power. And it's again a patented product under the U.S. patent 11542797 as of January 2023. If you'd like more information on this system or have more questions or would like to look at some opportunities, if you do have some tapered or multi-string wells, please give me a call at at or reach out on email. I'm cmason@kaizenws.com. That's KAIZENWS.com, or reach out to info@kaizenws.com. Ourselves or any of our authorized distributors across the United States can also provide this service in conjunction with us. So yeah, look forward to any calls. If you got any questions, comments, thoughts on this, please leave them in the comments below. And I would look forward to having a further discussion and see what kind of opportunity we have in the United States and in Canada for these tapered plunger lift systems that have really proven very successful in our overseas applications. Look forward to hearing from you. Have a great day.